Alrighty guys, let me make sure I've got the recorder going. Yes we do. And we're not muted, and the mic is on. The force is with us. Okay, so here we go. We know this is not a while loop because the line is not going back up to the diamond, so that means it's an if. It's an if with two cases, but really it's an if with only one case. If this is true, we do something. If it's not true, we do nothing. So that's an if with a block of code underneath it, but no else. Then there are two cases. Again, we know it's not a loop because no line's going back up to the diamond. If this is true, then do something else, do something else. Now when I do flowcharts, I feel like putting the word else up here rather than no, or putting it after it or something, because when in flowcharting classes, people always want to put the word else inside a block, like it needs to be in a square block or whatever. But it doesn't. It's just a state. The state is if it's true, you're coming over here, but if it's not true, you have else, and then you're doing this. Then we have change conditionals, and I'm pretty sure that we did this. We did do this, correct?
Yes.
If, elif, yeah. Then there are nested conditionals. Nested conditionals are when you have an if, and if it's true, or if it's false, you could nest it on either side, then it branches off and has another if statement. If you have money and you're hungry, print eat. Now this flowchart's kind of backwards to my opinion. I always put yes going off to the right and no going off to the left because you always tab and that sends things to the right. But whatever, we get the same idea. So if we come down here to this page, I've got a couple of flowcharts that we're going to go ahead and code, and they're trivial. This one says, let's see if I can blow the font up. If x is less than 10, print yay. Well, that kind of implies that we need a variable named x, but we'll make one. So I'm going to do file new. I'm going to save it as, I'm not feeling very creative, so I'm going to call it Feb1. Alrighty, so if x is less than 10, and you'll see that my flowcharts I put the word if there. Why hide it? Okay, if x is less than 10, but that's a problem, we don't have x defined yet. So yeah, we could ask them for it, or we just assign it a value. Whatever. If that's true, we're going to print yay. Then there's another flowchart down here. What kind of code are we going to use to get this one going? If else. Yeah, it's not going to be elif because we're only doing one thing or the other. Whoops, wrong one. This one's based on y, so I'm certainly going to need a y. I'm arbitrarily giving it the value of 100, whatever you want to do. If y is less than 10, print awesome. Else, colon, print drats. And I'm not saying colon every time. I'm trusting you to remember that each time we start tabbing, there has to be a colon before there. All right. Now I didn't draw an example of a cascade of ifs where you use if, elif, but we do have this one. What is this structure called?
Nested.
Yeah, that's a nested if because we're nesting this if inside the yes of this if. Drag this over, get it to the side here so we have room for our typing. looks like I'm going to need a z. So z is going to equal 120. Again, chosen arbitrarily. If we wanted to take the time, we could add code to ask the user for z, let them type it in, but then as we keep running these programs and we have to type in x, y, and z over and over and over, it becomes annoying. So anyways, we could make them random numbers. That'd be more cool. If z is less than 10, what do I do next? Well, we're in the yes side of it because we haven't put an else in it, so we're over here. What's the next thing I'm going to add? Yeah, I'm going to need another if block underneath it. If z is less than 100. And if that's true, I'm going to print high. This one, this else, belongs to this if block, so I need to make sure that those two are lined up. And in fact they are, that they have the same amount of tabbing. All right, now we're done with that side because we've hit the place where the two sides of the if statement join back together. So that means that we're now back to this if, and we're going to do the else. And we know that this else has to be lined up with that because these two chunks of code are equivalent. So else colon print low. Just a second, I'll go back to that. Alrighty, I'm going to run it and see if I have any egregious syntax errors. Yay, drats low. Sounds good to me. We're just demonstrating structures rather than trying to accomplish anything particularly awesome. Alright, did anybody come in late and need a copy of the code that we've typed so far? Alright, cool. Anybody need me to eyeball their page, their screen? Okay, now veering aside a little bit, go over to your shell, not your program, and type import math. And then do dir parentheses math into parentheses. It gives you a list of all the functions in the math library. That's just kind of a, oh cool, because I saw it. Any library you import, you can do that on and get the list of functions. What are some of these functions? What would floor do?
The division where it rounded it down.
I don't think it's going to do division. If we do this.
Or rounds down.
Yeah, if we do this. Floor of, yeah, 1.25. Nope. Excuse me, math.floor, 1.25. It's 1. It rounded it down. Just like ceiling, C-E-I-L, would round it up.
So if you use pi on there, then you...
It was lowercase, yeah, so you would type math.pi, print math.pi after you've imported it. And there we go, to about 16 digits of precision. Alrighty, catching exceptions. If you've taken an earlier class, you probably remember that there are 3 broad categories of exceptions, and maybe I've talked about them in here as well. There are syntax errors. Excuse me, not 3 categories of exceptions, 3 categories of errors. There are syntax errors, and what else? Logic errors, known as semantic errors. And then there are runtime errors. So syntax error is if you just have something spelled wrong, or you have the words in the wrong order, or something like that. You're trying to tell somebody how to go to Walmart, and you say, go west 10 spreaders, then north 20 miles. Now we could make an assumption that they just mistyped the word miles. Humans are pretty smart at figuring out patterns and things. But we don't know whether that says 10 feet, 10, light years, 10 miles, whatever. So that's a syntax error. You can't really understand it. Or if this was reversed somehow. If the numbers were mixed in before the goes and stuff like that, we might be able to figure out what it means, but it wouldn't be written in good English. So those are syntax errors. Logic errors are when you have the spelling right, you have all the syntax correct, but really it's 10 miles north and 20 miles west. So we follow those instructions to the letter, we understand them perfectly, and we wind up in the wrong place. That's a logic error, or a semantic error, some textbooks call it. So syntax error is a mistake in syntax. Yeah, that's real obvious, isn't it? You didn't put a colon in the right place. You put too many tabs. You put too many closed parentheses. You didn't put enough closed parentheses. You didn't put quotes around a string. All of that kind of stuff are syntax errors. You put a space between the equal when you're trying to write if a is equal to 10. You put a space there. That's a syntax error. Then the third kind, runtime error. Runtime error is when it runs into an unexpected state, not because of a syntax error, not even because of a logic error, but due to something beyond your computer's control. For example, if you were trying to go north 10 miles and then 20 miles west and you ran out of gas. Is that the fault of the instructions? Not really. Maybe the instructions were supposed to say, oh, by the way, if you don't have enough gas, don't do this. But usually when you're telling somebody how to get to your house, you don't tell them that. So runtime errors. Run out of gas. The car explodes for no reason. Friend calls you and needs a lift. That kind of stuff. It's stuff that's unexpected. There's no way that the instructions could have covered all of these cases. In computer terms, when your program's running, you can also run into runtime errors. Your disk fills up with no drive space left. Or you're trying to open a file and the file doesn't exist. Or you're trying to write to the D drive and you don't even have a D drive. Or you're trying to open a connection to a server and the internet is down. Anything that's beyond the control of your program to dictate is a runtime error, and it will crash your program. Here's an example. Let's go back to idle. And we're going to get some input, and then we're going to convert it. Print, enter an int, x is equal to input, x is equal to int x. And then let's print it out just for good measure. We made them type it in. We may as well display it. Now the syntax for this is perfect, assuming I did not make a typo. Let me close my shell and reopen it. I type in 20, it prints out 20. No syntax errors, no logic errors. Everything's great. Then some sneaky user decides that they want to type in 10.0. It blows up. It displays a red error message, and then the program stops running. That's not ideal behavior. If you were using an internet browser and you tried to open up Amazon and it couldn't reach Amazon because you typed in 2 periods rather than 1, you don't want your browser to quit. Then you have to relaunch it. Or worse, what if you're typing your thesis and you click save and the file couldn't be written to for whatever reason? You had taken out your flash drive, so instead of telling you that the file could not be found, it quit. Word quit. My thesis. So it's up to us to make sure that we try to handle runtime errors. Now you can go insane trying to handle every possible error condition, but you need to handle the reasonable ones. And usually if you work in a team of programmers, there'll be people dedicated just to testing the software. Because when you write the software, you test to make sure it works. And then you go, woohoo, it works. But when the user is using the software, they're not going to be concerned with doing everything just exactly right. And they're going to find bugs in your program. So the testing department tries to make your program crash. And so you wind up hating them. I'm kidding. But so you need to think like a tester when you're writing a program. Not only did my program work when I gave it good data, but did it work when I gave it bad data? So this being the most common or the easiest problem to reproduce, entering bad input. Another thing that could cause it to crash is if we just put in a decimal point, because that's a float rather than an int. So if I type 10, wait, I've already done that. Or I type in a word, enter an integer, 10. It's still going to blow up because I could not convert that. There is a way to solve. It's called exceptions. You precede the dangerous code with the word try. And then after the code that could blow up, you put the word except, which means catch an exception, and you put what's supposed to happen if a problem arises. So if there's a problem anywhere in these 3 statements, execution will automatically jump to here and do this print. So we can do that. Let's go back to our code and put a try catch around there.
I didn't know there was an except.
Why don't we? The only thing that could go wrong here, though, really, is just this conversion. So let's just put our try catch around it. The example showed doing it around the input and the conversion and the printing. Well, input I've never seen crash. Printing I've never seen crash. Conversions I sure have. So we're going to put try and then colon there before our conversion. We're going to tab that over. And then we're going to put the word except, and it's not tabbed. And we need to give them a clue that something bad happened. Print, you did not, or not an integer, assuming 0. Well, we're not even letting them try again at this point because there's no loop involved. But that's the next thing you do, is you force them to get it right. But here we go. At least assuming 0 in this case is better than just crashing the program. So I run it, it says enter an int, I type in a good number like 10, and it prints it out. Notice that this print here did not happen. Why? Because this is kind of like an if statement. If a problem occurred, go in here. But no problem occurred, so it didn't go in here. But now I'm going to test it to make it fail. I'm going to run it again. Enter an int, 20.0. And it says not an integer assuming 0. really we would want them to type in a good value. And to force them to type in a good value, we would probably need a loop. So we'll hit this idea again. So we use try and except to catch runtime errors. Other languages use similar syntax. Java does this, try, and then the word catch, rather than accept. Whatever. Different words mean the same thing. Why don't they all use the same words? Well, then we wouldn't make as much money, would we? Okay.
They would be different languages.
Right. And I guess the thing to point out is that control jumps immediately to the exception clause as soon as the error happens. Let's demonstrate that. Right here, after we do the conversion, let's print something. So after x is equal to int x, I'm going to put, yay, you did it. Good for you. Who's a good boy? You're a good boy. Here we go. If a problem happens in this statement, it's not going to execute that one. It jumps to the except clause as soon as a problem occurs. That kind of makes it different than an if. Enter an int yo. 10.1. Not an integer, assuming 0. That still works. This time I'm going to enter an int successfully. 1. And it says, yay, you did it, good for you.
It kind of helps with troubleshooting, though.
Yeah, yeah. When you're troubleshooting, you may wind up littering your code with print statements trying to figure out where in the code it is. And there's an alternative to doing that, which is to go into a debugger and stepping through it line by line. And honestly, I've never used idle's debugger.
It
And
comes up with a red bar if there's a mistake. Take the colon out from try. And
well, yeah, I know that you can get syntax debugging, but a true debugger will let you pick a place in your code that you wanted to stop. It'll run to that place, and then you step through it line by line, watching all the values change. So we need to learn how to do that. And I've done it in PyCharm, but I haven't done it in idle. I believe that there's a way. I could be wrong.
I think that's why we use PyCharm.
I think you're right because I'm not seeing it. Somebody told me there was a debugger in it, and I'm not spotting it.
Oh, it's in the shell. Run it, and then debug with there.
Ah. Go to file. Whatever. We'll figure that out later. Or we'll start using PyCharm. One or the other. So runtime error is also known as an exception. Why? It's an exceptional condition. Your car blew up while you were driving. That's pretty exceptional. Yeah. Your friend called you and asked for a ride. Well, maybe that's not that exceptional, but you know, it's out of the ordinary. It's not part of your listed instructions. And that's why they call it an exception. So this is kind of nitpicky computer science-y, and even this text notes this, that this is a fine point. If you evaluate an expression with an and or an or, it doesn't always check both sides of it. We know what and or do. You don't necessarily have to type this. You can. Okay, I'll put it in idle so that I actually know that it's typable. You know. So we're going to do A is equal to 10, B is equal to 20, and then we're going to write an and if statement. If A is equal to 0 and B is equal to 20, colon, print nifty. Else, colon, print Which one is it going to print? Yeah, it's going to print And why is that?
Because it's not equal to 0.
Right, because A is equal to 10. And when you have an and, both sides have to be correct, right? I've drawn a truth table up here. Does that sound familiar?
Yeah.
Okay, so not the problem, but the way things get evaluated is it checks this side first. And if this side is false, it doesn't even bother running this side. We can prove that. Let's define a couple of functions up here, or underneath there. Define test A, parentheses, when we haven't done a lot of function definitions in this class, but why not expose ourselves to them? Let's print out, I said test A and row test 1, whatever. Let's print test 1, and let's return a false. Then I'm going to stop tabbing so that I can do define test 2, parentheses in parentheses colon.
Does that return have to be capitalized? Or false? Does that have to be capitalized?
Yes, it does. Thank you for saving me. Cool. There we go. Print test 2. Now we can see when these things work or not. And return a true out of here. Return true with a capital T. So if test 1, parentheses in parentheses, and test 2, parentheses in parentheses, colon, print, I don't know, Joe, else, colon, print Bob. Now is test 1 true? When it calls test 1, is it going to evaluate that as true or false? It's going to evaluate as false because test 1 is a function that returns false. It's really all it does. So there's an and here. But once it gets false out of this function, it's going to go, okay, I don't even need to do anymore. I'm lazy. No, it's not lazy. It's efficient. So it's not going to do that, and it's going to come down here, and it's going to print Bob. Let's test that theory.
If you had test 2 in front and test 1 on the second, it would check both of them.
Right. Okay, so notice when I ran it, it only executed test 1 because it didn't need to try test 2. And just like you said, if we reverse those, it'll do both of them.
Because test 2 is true, so it just runs the other one and says false. Or...
It's got to check them both. If the first one is true, it doesn't know whether the whole thing is true. It's got to keep going. It's kind of like I'm looking for somebody wearing a blue shirt. So I start in the front row. But I want to see if everybody's wearing a blue shirt. If both of y'all are wearing blue shirts, I got to keep going. And I got to keep going, and I got to keep going. Eventually I hit a row where nobody's wearing a blue shirt and I can stop. That's what this is doing, is it's testing everything, and since they're linked with ands, they all have to be true. But as soon as it identifies a false, it stops there. So if test 2 and test 1 print and else colon print Sue. And this time, after it printed Bob, it did call both of them. That's called short-circuiting. Short-circuiting sounds bad. Captain, the engines cannot take much more. They short-circuited. Whatever. No. It just means that since the first part was false, it has no need to check this one. Or works the same way, but in reverse. If you have an or clause, let's rewrite this one as an or. If test 2, parentheses in parentheses, or test 1, parentheses in parentheses, print Dory, else colon, print Nemo. Since this is OR, only one side has to be true. It's like me saying, I'm going to see if there's anybody in the class wearing a blue shirt. Awesome, she'll be, so I can stop checking, you know. The first one I find that's true, I can stop doing the checks. So it's only going to call test 2 after it prints Ann or Sue. It's not going to call this one and this one because test 2 is the one that returns true. It already knows that this whole expression is true as a result of that, so it doesn't bother calling test 1. Is this super de-duper important? Usually not. But if it ever bites you, it will rend your mind until you spot the error, because it's not intuitively obvious. If no one had ever heard, if you'd never heard of short circuiting, then you would be really hard pressed to figure out why both functions weren't being called. And when does that matter? Well, if the function is doing something complicated, if it's opening a file or closing a file, or you open the file inside test 2 and then you're expecting to be able to close the file in test 1, but it never runs test 1, or vice versa. If those functions are dependent upon each other in some way, and you're not supposed to do that, you're not supposed to make two functions, you know. These should be independent tests. But if they were dependent upon each other in some way, like one opened the file and the other closed the file, then you might not get the file closed because it didn't run the second function. So that's called short circuiting. So if using AND, if the first operand is false, it stops evaluating. If using OR, if the first operand is true, it stops evaluating. And what is an operand? Have I used the term?
Yeah.
Okay. So an operand
Things
is something like this. Yeah, how to define it. But anyways, if you do something like A is equal to 2 plus 3, 2 is an operand and 3 is an operand. If you do this, if X is equal to 3 or Y, don't type this, is equal to 4 colon. Well, OR is an operand as much as the equal signs are, but that's the operand for the OR. And that's the other operand for the OR. And if this evaluates to true, there's no reason to call that operand. Another time that this would take an effect is if you think you're a sneaky Pete programmer in Java or C++ or and you start putting pluses in here. And I'll show you what I mean. Let me delete that, but I'm going to say I is equal to 1 and J is equal to 2. And then I write something like this. If I plus plus equals 2 and J plus plus equals 3. What that plus plus does is it's the same thing as plus equals 1 in our language. So after it executes this, I is no longer going to equal 1, it's going to equal 2. And looking at this casually, we think that after this runs, I is always going to equal 2, because look, we added 1 to it, and J is always going to equal 3. That's not the case. We do know that this is always going to be checked, but this one is conditional. Sometimes it will be called, sometimes not. So J's value will vary based on whether this was successful or not, and that may not be the behavior that you're looking for. So you can be too clever by half in writing languages that support the increment operator. We don't have to worry about that, but y'all are not only going to learn Python for the rest of your life. Debugging. The traceback that Python displays when an error occurs contains a lot of information, but it can be overwhelming. The most useful parts are usually what kind of error it was and where it occurred. So syntax errors are usually easy to find, but there are a few gotchas. Sometimes the error actually occurs on the previous line. I don't have a good example of that, but I remember when I was walking around and helping somebody find it, it said the error was on this line, but the problem really was that something had been left off of the previous line. But it does tell you a line number, so you can zero in pretty closely on it.
If you take your bracket after Dory off, we'll do it.
Okay, yeah.
Net.
Let's give that a shot. So check this out. The cursor showed up on that line. And you stare at that for a long time. Man, I'm pretty sure I typed else right. What's your problem? Yeah. So then finally you spot the error there. Same kind of thing with the line number errors. So if you run into an error, I is equal to 1 divided by 0. Let's see if that gives us a runtime error of some kind. Divide by 0 usually is. There we go. It gives us a line number. It says 87. And it gives us a nice technical explanation, 0 division error. And then it gives us a more plain one. And in this case, it even showed the line of code that caused the problem. Sometimes it doesn't look as clean as this. This is pretty much grabbing us by the neck and telling us what the problem is. Sometimes it's not as clean as that. But what you got to do is go to the line that it specifies and start staring at it. So line 87. You find your line numbers down here in the corner. I can't see them because my window's expanded too large. There they are. Line 87. What do you know? It's that line that I'm already sitting on. Glossary. The body. Now, I don't recall what they're calling a compound statement. But if we're looking at our code, this is the body of code that's part of the if statement. This is the body of code that's part of the else statement. The whole thing is a body of code that's part of the program. We have a function defined. This is the body of that function. This is the body of that function. So pretty much each time you do an indentation, you're creating a new body of code. If we go up here, all of this is the body of that if clause. And this is the body of that else clause. However, this is the body for that if clause, and this is the body for that else clause. Usually you don't talk about bodies of code except when you're talking about like loops and functions. I'm not usually going to say the body of an if statement, but you can. What if the if statement has 100 lines of code that's indented underneath it? It's perfectly legit to call it a body. What is a conditional statement? It's one that controls the flow of execution. If, else, while. And the condition is the statement after that word, after if, that evaluates to either be true or false. And since it evaluates to be true or false, it's known as a Boolean expression. A compound statement. A compound statement is one that consists of a header and a body. The header ends in a colon, and the body is indented relative to the header. So if we were going, and by the way, I'm not going to ever quiz you on that definition. If we were going by that, then this is a compound statement. Here's our header, and here's the body. Here's our header, here's our body. If, that's our header, that's our body. You get the idea. Where's our functions? Right there. That's the header of the function, and that's the body. Now, when I use the word header, I'm referring to a function. I don't refer to the header of an if statement. But according to this text, you could. We know what a nested conditional is, nested if statements. We know what short circuiting is. Alrighty, exercises. Rewrite your pay computation program, that sounds like it's assuming we've already written one, to give the employee 1.5 times the hourly rate for hours worked above 40. We can do that. That won't be hard. But why don't we make it a new script, because this thing keeps growing endlessly. File new. This is payment to, or pay to. So do a file save as call it pay 2. We have to ask them for the pay rate. We have to ask them for the hours. So rate is equal to input rate, question mark. We have to convert it to a float. Rate is equal to float rate. And then hours is equal to input hours, question mark. And then hours is equal to float hours. There's always more than one way to do this calculation, and I've had students argue with me whether the way that I was doing it was correct or not. And finally, I just had to demonstrate, well, look, it works the same way. And it's just because they have it in their head one way. But if you're going to do time and a half for more than 40, one way to do that is to calculate the total and then calculate another total only for the hours over 40, and then add those two together. So let's do it that way, in my opinion. Let's define a variable called extra or bonus. And bonus is going to equal 0 unless we're lucky enough to work more than 40 hours. And so the total is equal to the hours times the rate. But now we want to give them a bonus. But the bonus is conditional. What are we going to do next?
If else.
Yeah, why not use an if statement if hours greater than 40? So if hours greater than 40 colon, we need to calculate our bonus hours. So I'm going to call it BH is equal to hours minus 40. And like I said, there's more than one way to do this. And then bonus is equal to the bonus hours times the rate divided by 2.
Why are you dividing it by 2?
Because it's time and a half. You don't get double pay. Right. You just get 50% more. And then lastly, we want to add that bonus to our total. Or if we want to keep those values separate, we could create a third variable to hold the sum of the bonus and the total. Paycheck is equal to total plus bonus. Now let's print out those three values. Print the total, except let's describe what it is, so let's put a string in front of it. Total equals colon, comma, total. Let's print the bonus. Bonus equals quote, comma, bonus. And then paycheck equals close quote, comma, paycheck, parentheses. Let's try it out. I earn $10 an hour. I work 10 hours. That's $100 with no bonus. I'm going to test it again with 40 hours, and then I'm going to experiment beyond 40 hours. So let's run it again. Rate $10 an hour, 40, that ought to be $400. Now, if I work 41 hours, I'm going to make $410, but I get a bit of a bonus. How much is that bonus going to be? It's not 100% of every hour over 40, but it's half of that. So it ought to be $5 extra. Let's try that out. So my rate is 10, my hours are 41. My total was 410, the bonus is 5, and the paycheck is 415. we could improve this program if we so chose by reducing this to a single line here. But I don't much feel like doing that. That would just actually make it harder to read.
I'm getting a completely different thing. I put in the same thing you did, but
Well, cool. Let me come look. Okay, now I want you to make a change to the program. The change, I'm going to list up here at the top. You don't have to write it, but if they type in bad data for the rate, tell them and set rate equal to 10. Then if they type in bad data for the hours, tell them that it's an error and set rate equal to 40. How are you going to do that? You're going to use those try except words again. So I'm going to bring the code up that had that try and except and put it here so that you have something to model your code after. And then I'll come along and I'll do it too. But I want you to take a stab at it. There's really two approaches to handling bad input. Well, there's more. One is if they type in something bad, you just say, forget it. You chuck it. Another is if they type in something bad, you force them to type in something good. That's actually better than what we're doing here, which is just assuming a default. But if I ask you to make your program error-proof, and it seems to you that assuming a default would be enough, I don't specify looping, then you could just do that. So this is the one that's a problem child, and that's the one. So we need to enclose both of these float commands, float calls, and tries. So I'm going to put try colon in front of that rate equals float rate. And I'm going to do the same thing down here in front of this hours is equal to float hours. So I put the word try colon in front of each of those and I tab each one of those over. Now I need except blocks to match those try. So except colon, let's print an error message. Error. Assuming 10, 10.0, whatever. Then we actually better do it. Rate is equal to 10. Just saying that we did isn't enough. That's that first except block. And then we need one under this one too. Let's print out our error. Print error, assuming 40, and then hours is equal to 40. Now I'm going to run it and I'm going to type in garbage data for both, and hopefully it'll default to 10 and 40.
I just typed in strings.
Yeah, that's what I'm going to do. Like, hello, oops, and then goodbye.
Yeah.
My mistake. All right, anyways,
What's your,
400.
That's how that works.
what's your rate again?
Yeah. Hell no, we won't go. All right, so anyways, it worked. Now you had an interesting problem that was driving us up the wall because this one
It's a copy and paste.
was the word rate. And the code all looked good. But what happens when you run it? You type in two words. Heck no. What happens is it doesn't flag no as being an error. And then everything ran on happily. The reason why is it took this float of rate, which already is a valid number now, it's equal to 10. And it converted again to being a float, which, it doesn't change it at all, and put it in hours. Things like that can really drive you crazy because you don't spot it instantly. Hey, what? Rate. Nope, hours. I was crossing rate and hours in my mind. Came up with hate. I'm sleepy. Here we go. That would be an argument for combining the conversion and the input statement in one line. And I'll show you what I mean. Change this by getting rid of that input statement. Getting rid of that word right there. And changing this to saying input, please enter rate, quote. Alright, I'm not going to do the other one like that. But do you see how that avoids any confusion about, you know, which variable is being converted?
Well, what if they put in?
What if they still don't put it?
Yeah, what if they put in like?
Well,
words?
if they put in bad data, we're still going to assume that the rate is 10.
So it's still the same.
It's just that we don't have to have this double use of this variable. Hours is equal to hours. You know, here we have the variable appearing 3 times. Hours, hours, hours. Any 3 of those is a chance to misspell something or put the wrong place. Here we just have rate once because we're using the feedback from this function and immediately passing it to the float function and immediately storing that in rate. So this code is a little bit cleaner up here at the price of having, you know, a function nested within another function. All right. That is a good place to stop. The only other thing I could think about is to ask you all to write a different version of the logic for calculating overtime. Because there are like 3 or 4 different ways that'll get you the same answer. But, nah. So we'll make a Dropbox for this, upload it, and we are done. So drop Pay 2 and Feb 1 into in Class E, and we're good.